It's day 24 of Advent of Code. Today is Christmas Day here, so I will try to keep it a little bit quicker today. So I already prepared the description of the problem. So we have some crossed wires and we have gates that are getting some inputs and getting a specific output. So AND gate is adding two binary inputs and giving some output. Then OR gate is classic OR, XOR is classic XOR. So basically just binary gates, and we have some inputs and we then have some connections. So we see what gates are connected, which and what is the output gate that we get. And finally, for a given input, we are looking to figure out what's the Z gate, what are the Z gates outputs, and then using those Z gates, we are trying to get the output value, which we then convert to from binary to decimal, and that's the output of the problem. So let's try to solve this. So I will take this input, put it here, and then try to solve it. So let's do. We'll have some kind of hash set, or rather this way, dictionary string int values. We'll have a dictionary of hash set or rather let's create a class connection. So this is gonna be public string input 1, input 2, string output, and then we will have some operation. So we'll have a public enum operation and or XOR, and then we have the values. So I have some kind of private int evaluate, and we'll have we'll read in the gates the connections. So list connection, and what we can also do is have the gates will be in like each gate will be input of something or output of something and then input of something. So dictionary, again we have the same gate as input to multiple things. I think yes, that is making sense. So we could have connections, something like that. So connections for gate, so something like this. So this will be our connections will be a list of connections, then a list of values. Now for the input we will do while input reader read line async is line and sync line. While we have not empty line, we will have so those are the input values, right? So input values list string int, so those are input values. So for line parts will have a line split, and we'll split it by character of these characters. So gate name will be parse 0 and value will be parse 1. We'll parse it into parse. So we'll have input values. We'll add so this will be dictionary of string int. And now have a dictionary string int values. Now we need to read the connections. So our connections. So we read the empty line here. So we now will be reading the individual connections. So for while and we can put it as line, we'll split the line first by we can split it by space, basically. So we can split it by space. And now it's gonna be input 1 will be connection. This, then output will be for operation, the operation there. So operation public operation will be get set, and we need to parse that operation. So parse 1 switch, we switch it by exactly this. So that's operation. So 0, 1, 2, 3, 4. That fits exactly what I needed here. So that's good. Now, based on this, we get all the connections. And finally, we will evaluate. So result equals evaluate. And we'll pass in some initial. So input, so some of the input values. So this will be input values. And we actually don't need a question mark there. So the input values, and we output the result. And we don't need this. We just given the initial values, input values from here. So that's good. Now, given those values, we will start evaluating the input. So gates to process. So we know the values of these gates. So I will do while gates to process count greater than 0. And actually, we can do should actually actually we can do it's more simply here. So we can take so we need to find a way to process this efficiently from start to finish. And a good way to do it would be to sort this topologically based on the inputs that we know are already available. So we can start with the ones that we already know. So see. We can do kind of dependency graph. So we can find always the one that is not dependent on any other that are not processed yet. So you could do we could do sort them by topologically. So essentially, what we would do is to take all the inputs to figure out what are the dependencies between each, and then try to always find the one that or the ones that are not dependent on anything that we haven't processed yet. So we can do a list string topo sorted. And we'll be sorting them topologically. So given the input, we will be looking for, actually, let's see. Do I need to do this? Essentially, we can just evaluate. I mean, the input. The input is not too huge, so we should be able to just walk through it input by line by line, and always just check which one is possible to evaluate. It might be easier because like it doesn't seem necessary in this case. So we will be doing while values like, let's see, we have with hash set string gates. I have a list of gates. Then we will be adding gates add connection input 1, connection input 3 and 2 and output. And we will also make sure to add all the gate name. So we'll add all the gates. So and we will be checking while values count less than gates count. So while we have some gates that are not processed, we will be checking for each connection in connections, and we will check if values contains, well, if we don't know the value of connections output, connection output, and values. Oh, maybe we can do actually this. So hash so processed connections, a new hash set connection, and we will do if those connections contains connection. So we didn't process it yet, and we check if values not contains connection output, and values contains connection input 1, and values contains key connection input 2. So basically we know the value for both inputs, but we don't know the value of the output. So this way, or actually we can output equals connection values, private for int evaluate connection. So we'll have a connection with values. We get the values, we get an operation, yes, we OR, XOR, and we will get the output here, which is okay. So actually we can just directly output it there. And we don't have to return anything. And we will then add the connection to process connections. And when it's done, we should have all the outputs done. So gates. So we find all the gates where it contains the key. That is where G starts with Z. Order by G. So we order them by name and then just do list them. So actually we can do this here. And we don't have to return anything. We can just do this and then we get the output from it. So not get set value. So that will be the output of set gates. So private set so private int set value. So it's going to be a list of string set gates and values, and that we will do binary string join. We will join them by as a string. Actually, we need to order them. Right, we need to build it up from the end. So these are most significant bits. So we actually have to do it order reverse. You have to reverse them. So reverse. Oh, right. So we reverse them, and then we select the values, and we get the binary number, so we convert it to int32. So that should be it. So hopefully this is enough to get the right result. Yeah, it's not the cleanest code, but it should be enough. So it's day 24 and it's 2024. Yes, it seems okay. So let's try the actual big input. Save it here. Big input file. Too large or too small. Okay, so it's a bigger number than I expected. So let's do instead of convert to int32 will be to int64, and it's going to be long, and this is going to be long. So maybe now. Okay, this is the result. Quite a big number. Indeed. And it is correct. Okay, so we had the first part solved. Now let's go to the second part. So for part 2, I actually had to solve this kind of asynchronously because I didn't find enough consecutive time during the day to actually record and solve it. So the idea behind this problem, which is definitely the hardest problem of Advent of Code 2024, is that we know that the system that we are given is actually summing two binary numbers. And so one binary number is given in the X inputs and another is in the Y inputs, and the result should show up on the Z gates. And the thing is that these Z wires actually, the idea is that this should work for all possible binary inputs. So not only for the one that's in the input that we are given, but we can just plug in any X and Y numbers and we should get the correct sum in Z numbers. So that's the idea behind this. And we actually have this system now that allows us to sum the numbers correctly. And we unfortunately know that that what we're given in the input is not correct. There are 4 swapped outputs of gates. So 4 gates have swapped outputs. Basically it means that for a pair of gates, the output Z05 here should be here, and conversely Z00 should be here. So there are 4 such pairs where the outputs are swapped, and that means that the result that we are getting is not correct, or at least not correct always. So our goal is to find these 4 pairs of swapped outputs and then output all 8 outputs that are not correct in the alphabetical order basically. So quite a complex thing, especially as to actually run this, we actually have to run the whole thing and validate it against potentially every single input number. So the solution that the approach that I took is that I use GraphViz to visualize the system, and you can see that it always kind of takes the input values and then does some ANDing, XORing, and generates a Z output. And that continues to other inputs. So basically Y02, X02, and kind of combines things and then gets us the Z02 and so on. It kind of goes sequentially. There are no really big diversions from that logic. So using that knowledge, I implemented this improved version of the first part. Basically, I also extracted the connections, which should be actually gates in here, and basically extracted some logic to make it easier to understand. But the main logic is here. So we have find fix for faulty connection, which takes index of the first invalid Z bit that we want to fix. And this method kind of takes all the wires. I have incorrect naming here, so it shouldn't be gates, but it should be wires, and the connections are actually gates. But we get the confirmed ones and the suspected ones that are suspected from being incorrect. So the confirmed ones are those which we already know that are correct. So in my case, the first incorrect results when I tried some input numbers were happening at the Z12 node. So it means that until Z11, everything should be correct. Everything Z11 depends on should be correct. So only the things that Z12 depends on, but as Z11 doesn't depend on, can be problematic. So those are this one, those are actually inputs, but those are actually, which are those? There are no, yeah, right. So basically, Z12 itself can be incorrect, and it is actually incorrect. So the idea is that it's swapped with this one, and everything from that Z12 depends on, and everything afterwards, everything that's not included in Z11 can be faulty. So what I get is confirmed gates. Those are the ones that the previous valid gate depends on. Then the suspected, which are the dependencies of the invalid one, and also swap gates, which are all the gates except ones that are confirmed. So what I do is, for each suspected gate, I tried all possible swap gates and try to test if I swap them, if it actually improves the first index where I get invalid value. And if it improves, then I return that as a result. So that testing is quite simple. I just swap the gates and then run it against some random number pairs, and also against numbers where I have one on each different position of the 45 bits. So I can try various things to see what is the minimum index where I get an error during the sum. And once I find it, then I just return the minimum index. I have some short circuiting here. So if I find an index if I break some previous number, then I immediately break, but it's just to make this faster. But as a result, I return the minimum fault index that I found. And if I improved it, so if, let's see, so this is if I improved the index of the fault, so I moved the error forward to some later Z gate, I return that as a solution. And then the solution is in this fix. So I add my new fix into swapped results, and I swap them actually, and then I move on to the next faulty index. And until I have 4 of those, I continue. And when I have 4, I know that I fixed 4 issues in the circuit, and as long as the input is valid, and it should be, then I just can output the names and return them. And that's what worked. So I found this string, which was the correct solution to this problem. So very complex one this time, but ultimately I'm happy that I found the solution and it worked. So there is just day 25 left, and I will be also doing a ChatGPT solving this problem video. So stay tuned for that, and see you next time.